Okay, so this is just going to be a quick video on some helpful directions that will definitely help on the exam. Basically, when working with Chapter 6 problems, again, there are two questions that are really important. I'd suggest asking myself this every single time. Memorize it if you need to, but basically, first you need to always identify if there's a collision involved, because working a problem and finding out there is no collision, or thinking that there is a collision but there really isn't. So basically identifying a collision is the whole key to actually being able to understand and apply what you have learned to that problem. So first of all, we always ask, is there a collision involved? If so, is it elastic or inelastic? Now I see that he's actually also added on if it's perfectly inelastic, so I'll probably start creating a video on that as well. That is another concept that is probably very good to learn. So if so, is it elastic or inelastic? Remember the qualities that we attributed to those. If you haven't, then please go back and watch the video. Then you'll be able to know whether it's inelastic or elastic. Actually, I'll give you just a quick insight into what the inelastic and elastic is. Elastic is basically when two objects they both have some sort of, well, either one has to have some sort of momentum or motion, while the other one is at rest, or both can have momentum or motion, and they must collide and bounce off, but they never stick together. Whereas the inelastic, they stick together and they move as one in one direction. And again, one can be at rest, one can be moving, or one can be moving, and the other one can be moving as well. Question number 2 is basically, if there is no collision, are we dealing with one object or two? So here are the formulas. This is basically, I'd suggest studying this, is a breakdown of formulas. So basically, if there's no collision and there's only one object, then you can use basically the momentum equation, which is P equals mass times velocity. And if there's two objects, then you're going to actually set mass times velocity of one object equal to mass times velocity of the other. Now if there's a collision, these are basically the exact same formulas that we used for inelastic and elastic. And you can just work off of that. And then also I want to cover ratio problems just quick. So they're a lot harder to explain, so it's better to show these in examples. So I'm just going to show you just a breakdown of a problem. So here's our problem. A meteorite explodes into two pieces, one having 3 times the mass of the other. Okay? What is the ratio of the velocity of the fragments? So we know the meteorite explodes into two pieces, okay? And I can probably even draw it out. Let me see if I can bring this in. Sorry, this is my other little project I was working on. Basically, we actually have one meteorite, which I'm going to pretend this is a meteorite, and it splits up into one piece. We'll say it's like this, and it splits up into another piece, this like this. But it's in a basically a one to basically. Oh, hold on, let me just bring it out here. One having 3 times the mass of the other. So this has one mass. Okay, so we're gonna say maybe this is like we'll say this is 1x mass, and or actually no, yeah, well, 1x, which is basically x, and this will be 3x. So it's 3 times the mass of the other piece. Okay, so that's our diagram. It's always good to draw out a diagram. I found it helps so much, and this should help you quite a bit. So let's look back at what we have. So we see that there isn't a collision involved. There's actually no collision involved because you have to have two objects. One has to be at rest and one has to be moving. It doesn't even mention it moving. All it mentions is that it basically broke apart and split, right? And one split into x and the other one split into 3 times the amount, or 3 times the mass of the other piece. So that has nothing to do with collisions. All we're looking for is basically the velocity of the fragments, right? So since there was no collision involved, these never hit each other, then we know that there's two objects involved because it's split into two pieces. So we can actually use this formula right here for two objects, mv equals mv, which is mass times velocity equals mass times velocity. And what we can do is we can plug in our 3 that we know. See, so actually right here it puts the 3 is put in indicating that one object's mass is 3 times the other mass. That's all we're saying. So even if you wanted to, you could put 1 here. You could say 1 mass times velocity equals 3 mass times velocity, but it's not necessary. 1 times mass times velocity is always still going to equal just straight mass times velocity. So right now we're just going to be solving for velocity ratio so the m's can be crossed out. Okay, so basically what we can do is we can just actually cancel out the masses, because when you can just divide on both sides by mass, those will cancel out and you'll be left with velocity. And see, why don't we cancel out the velocity? We're looking for the velocity, right? So we're actually going to keep that in there. If we were solving for the mass, that'd be a different story, and we'd be able to cancel out the velocity and leave the mass. But we can actually transfer that 3 and use that as our velocity. And all we're going to do is we're just basically plug in, because we know the 3 to 1 ratio. So we're going to balance the equation now. So if the v on the left side is 3, then the v on the right must be 1. So you have a 3 to 1 ratio, because whatever is on this side must equal whatever is on that side. So it is a 3 to 1 ratio. So that's just a basic ratio problem. Yeah, you shouldn't have too much trouble with that. Even if you didn't want to work it out this way, you already know it's one having 3 times the mass of the other, then it must be a 3 to 1. But if you want to work it out and show your work, because they're always going to look for your work, then you're going to definitely need to use this equation. This is what they'll be looking for. I hope this helps you. I hope this helps you on your exam. Happy studying. See you guys later. Bye.